Hey everyone, and welcome back. In this lecture, we'll pick up from where we left off last time, and then have a look at how to create different chart types in Matplotlib. Let's jump on over into our Jupyter notebook and get started. The first chart type that I'd like to show you in this lecture will be the scatter plot. This is a chart type that we looked at in Excel, so it'll probably be quite familiar to you. To demonstrate it, I'm going to go ahead and use NumPy to create two random number arrays. So we'll have x, which will be equal to np.random.randint, and then I'd just like it to start at 1, and then have a maximum possible value of 100. And then I'd also like a size of 100 too. And then I'll just copy this and paste it for our y variable. Okay, and now that we've got our data, let's go ahead and use Matplotlib to create a scatter plot. The function for this is simply plt.scatter, and then we can see here that we've got quite a few different arguments. Most of these are for customization, but the two most important ones are our x and y arguments up here at the top. And this is the data that we actually want to plot. So I'll just go ahead and pass these in as x and y. So the two variables that we just made. Okay, and there we go. We now have a scatter plot showing our randomly generated x and y values. And this is a lot easier to interpret and understand than it is to look at the values in our actual arrays. We've got a whole lecture coming up next on how to style and customize our plots in Matplotlib, so I won't go into too much detail now, but I will make a few small changes to the color and markers. I'll go ahead and change the color to green with the same color or C argument for short that we used last time, and then I'll change the markers to stars, and then also I'll increase the size a little bit as well. I'll try 200 and see how that looks, and I think here 200 might actually be a little bit too big, so I'll go ahead and change this to 150 instead. Okay, perfect. So that is how we can create scatter plots inside of Matplotlib. Next up, we'll move on to looking at bar charts. Just to recap what we learned in our section on data visualization in Excel, bar or column charts work best when we want to visualize categorical data. For this example, we'll compare sales of different products from different categories. I'll create a categories list with a few different product categories, including smartphones, laptops, tablets, headphones, and accessories. And then just below this, I'll create another list for our sales, which will be the sales for each of these different categories. Okay, and now let's say that we want to plot this data on a bar chart. The function that we'll use to do this is simply the plt.bar function. And then our first two arguments will be for our data, and these are called x and height. X is just our x-axis, and then the height is basically just our y-axis. So the values are numbers that we actually want to plot. And this will be what determines the height of our bars. I'll set our x-axis to be the categories list that we just made, and then the height will be our sales list. And then running this will return a bar chart, and this makes it very easy for us to see that headphones are our best selling product, but we may need to do some more work or advertisement on our accessory products. There are, of course, a load of visual changes that we can make to our bar charts. We've already looked at how to change the color, but something that can be very helpful is to add in an edge color to our different bars. And this really helps to visually separate the bars and can overall make your bar chart look a lot nicer. So I usually set the edge color to be black. So I'll just put in edge color equals black, like so. And then our bars now have a nice black border. We'll now move on to looking at histograms, which, as we know from our section on data visualization in Excel, these can be used to show the frequency or distribution of numbers by grouping them into bins. Let's use NumPy to create an array of randomly generated numbers, which we'll say are the daily temperatures. And then I'll just say that is equal to np.random.normal, as I'd like a normal distribution for our temperatures. I'll set the log to be 15, as I'd like a mean of 15, and then a scale of 5, which will give us a standard deviation of 5, and then finally I'll set the size to be 365, so that we get a single data point for each day in a year. And then this is just a quick look at what our actual values look like. Okay, and let's now use the plt.hist function to create our histogram. So plt.hist, and then let's pass in our daily temperatures. Perfect. We can see here that we do have a normally distributed data set, with the majority of our values falling towards the middle of our range, with a mean of 15, as we specified when we created our variable. If we wanted more granularity with our histogram, we could increase the number of bins on our histogram. And just to recap, each bin is just a specific range or interval of values within the dataset. So I'll just say here that our number of bins is equal to 20, and then when we run this, we'll see that our histogram is now a little more jagged, because there's now a larger number of bins with a smaller amount of values inside of each bin, which is what provides us with the increased granularity and greater level of detail. It can also sometimes be helpful to add in an edge color to our histograms as well, so that we can clearly see the start and stop points for our histogram, like we can see here. Before we move on to our next chart type, I'd also like to show you how to create a cumulative histogram. The main difference between a cumulative histogram and a regular histogram is that a regular histogram shows the frequency distribution of a dataset by dividing it into bins, as we can see here with this example, and a cumulative histogram shows the cumulative count or percentage of observations as part of the total number of values. And this will make more sense in a moment when we have a look at an example. I'll just copy the code for this histogram and then paste it into a new cell. But then I'll add in another argument, which will be cumulative, and then I'll set this to be equal to true. And also, just note here to make sure that your T is a capital. And then basically, what this is showing is how much each bin or group of numbers contributes towards the total amount of numbers in our dataset, which in this case was 365. We can see that for our first few bins, there's not many values in these groups, but for our bins towards the middle of our dataset, the jump between bars is much larger, and this is because there's a lot more values in these groups, which makes sense as this is a normally distributed dataset with the majority of the values falling around the mean. And then it levels out as we get towards the top end of our dataset and now have all of our 365 values shown. Okay, let's now move on and have a look at pie charts. For this example, I'll actually copy over the dataset that we used before for our bar chart, which had some information on different product categories and sales. Pie charts are also good for visualizing categorical data, but instead of comparing the actual values, they show the data as a percentage of the whole. Before we create our pie chart, I'm also going to quickly create another list, which I'll call explode value, and then I'll set this to include 0.1 and then 0 for the rest of our 4 other items. Let's go ahead and call our plt.py function, and then if we have a look at our documentation, the first 3 arguments are x, explode, and the labels. We'll have a look at the explode argument in a moment, but for now, I'll just say that x will be the sales list, and then I'll set our labels to be our products list. We could actually pass this data into our function directly, but it's much neater and easier to define this data beforehand and then just pass it in as a list instead. And then running this, we'll just create a pie chart with our sales data making up the pie chart slices, and then the labels have been set to our products list. The order in which these elements are in our lists will determine what label is for what value. For example, if we look at our sales data, the highest number is 600, which is our 4th element in this list, which if we look at our pie chart, we can see that this slice is the headphones label. The reason for this is that headphones is the 4th element in our products list, and if we were to change this to just test, then our label on the pie chart would also change to this as well. And let's also say that we'd like to add in a label for the percentage value for each of our slices too. To achieve this, we can use the auto PCT argument within our plt.py function. I'll add this in over here at the end, and then I'll say that this is equal to the %sign 1.1f and then another 2 percentage signs. And then if we run this, we'll see that we have our percentage values displayed for each of our slices. But before moving on, let's quickly go over how this actually works, as it can look a little confusing at first glance. Firstly, auto PCT, short for auto percentage, is the actual parameter or argument that we use to format the percentage values for each of our slices. And then percentage 1.1f and our 2 percentage signs is the actual formatting string. Breaking this down even further, our first part, so percentage 1.1f, specifies the format for our floating point number. And it basically means to display the number before the decimal point and then 1 after it. And then f is just short for floating point. And then finally, the double percent signs are simply used to actually display a percentage sign after our number. And the reason that we have 2 is because the percent sign is used for string formatting, so we need to escape this and then add in another percent to ensure that a literal percentage sign is showed. And that's the reason why there is a percentage sign before our 1.1f2, and that's to initiate the string formatting. So just to show you, if we remove these last 2 percentage signs, then we'd only get the number and not the percentage sign. And if we change this to be 1.2f, we get our number, but now to 2 decimal points. And then finally, for our pie charts, I'll show you what the explode argument is and what it does. Essentially, explode allows us to visually emphasize specific slices of our pie chart by offsetting or exploding them from our original pie chart. And this functionality is particularly helpful when you need to draw the attention to key segments of your pie chart. We've already created our explode values in this list here, so we'll just add in that explode is equal to our explode values list. And then here we have our same pie chart with the same data, but then the first slice for our smartphones has been exploded and pulled out a bit from our chart. If we wanted to pull our headphones slice out, as this contributes the largest percentage of our sales amount, we would change the 4th element in our explode values list, as headphones is our fourth category, and then I'll set this to be 0.5. Okay, and the final type of plot that we'll look at in this lecture will be box plots. I'll go ahead and copy over a little bit of code from the notebook file for this section, which just creates 3 random arrays with a normal distribution. Creating box plots can be done with the boxplot function, so plt.boxplot, and then to start off, let's just pass in our first array, which is class 1 scores. When we plot this, we'll get a similar output to what we had in Excel. So the box itself extends from the lower to the upper quartiles with a line in the middle showing the median. The whiskers then extend to show the range of the data, and then we have little dots here showing any outliers. And then to visualize the distribution of our 3 different classes together, we could simply pass in a list containing our 3 different data sets. And this will then allow us to easily compare the distributions of our scores across the different classes. Okay, and that there wraps up our lecture on some of the different chart types available in Matplotlib. There are, of course, some other more niche and more specialized chart types, but these will cover the vast majority of the work that you'll be doing as a data analyst. Let's go ahead and leave this lecture here, and then in the next lecture, we'll have another look at how to customize and style our plots, but this time in much greater detail. Thanks everyone, and I'll see you all in the next lecture.